Hey, good afternoon, friends. This is Datta Sapre, and I am your fellow student in the Machine Learning Foundation course for AIML with the Duke University. This is my project for the combined cycle power plant. We are trying to predict the electric energy output for a combination of gas turbine, steam turbine, and heat recovery steam generators. I'm a mechanical engineer, so this was particularly enjoyable for me. Bryan cycle, Carnot cycle, Rankine cycle, great information. But essentially, this is a machine learning modeling project. So I'll stick to the machine learning foundations criteria for this project which we were given to build this project upon. So first things first, modeling approach. It's It's pretty straightforward. We cannot be doing logistics regression. This is not a classification problem. It's not complex problem for decision tree or deep neural network. So I chose linear regression with essentially multiple regression method. So built two models. So that's the approach. Model building, I built two different models using two different sets of hyperparameters, and essentially picked about 80% of the data for the data set for training, and then about 15% for validation set and 10% for the test set for model evaluation. So we'll be looking at model evaluation using mean absolute error, MSE, RMSE, and so on. Model interpretation is fairly simple to interpret the model, and we'll get to the model and then look at it and then interpret it at the end. Regression helps with that. If it was a neural network, it would have been complicated. So as we talked about, right, we are trying to predict the power that this combined cycle power plant generates. So what are our hyperparameters? What are our parameters or features that make these environmental variables contribute to this power generation? Ambient temperature, vacuum, ambient pressure, relative humidity. These are the four parameters that I have taken into regression analysis, um, multiple regression analysis, and you can see that, you know, I added the add-in for data analysis, and then ran the regression models for this. Uh, the regression model gave me this regression here and the residual here. If you can see the R score, fairly good value for R score that shows the correlation is quite high. If you look at the MAE, which is the mean absolute error, I calculated that mean absolute error along with MSE and RMSE. And this is for model one, which I took all the different parameters that make up for this power generation, all the variables that make up for this power generation. So all the features are considered here. My second model is, however, limited. I took away the relative humidity from it, thinking that relative humidity may not have as much of a correlation, and predicted the power. Now, on prediction, and then taking a look at the residuals, and then drawing conclusions on mean absolute error. If you see, the mean absolute error here is 3.88 for this model. For the model one, the mean absolute error was lesser at 3.62. So the model with model one has got lesser error in terms of all of them. MSE is will mean square error as well as root mean square error. So model one is clearly the winner here, and my validation set proves the same, test set proves the same. The test set ran quite well on the model one. As you can see, here also the MA is 3.68. Though it's a smaller data set, What I gathered essentially is that ambient temperature has probably the most correlation or the most impact on our power generation um, as such. So that covers most of our rubric here. Again, multi-regression modeling with MAE as the validation or for model comparison, and model building was with multi-regression. Interpretation of the model, as I said, the interpretation tells us clearly that model one with all the features from the model are contributing to the final outcome of the power generation and taking away relative humidity. And I tried that with taking away vacuum as well. Gets lesser correlation, or the predicted power generation and the actual power generation deviates further. The residual is larger. So thank you very much. Please assess my model and give me feedback. I will be eager and keen to hear from you. Thank you very much. Appreciate you listening to me.